Wow, that one's intense. Wow, I'm sorry, everybody. That may have been really loud. So we now have 10 versions of our theme music, including this one.
I need longer hair.
Ooh, it's all the same lyrics on all of them, but
I like that.
I'm sorry if that scared
funny.
anybody. That was loud, or like woke up a baby in the next room. At least it was loud in my headphones.
It was decently loud. It wasn't crazy, but it was loud.
So I made some new theme music.
Noticed.
I was just telling Harrison a second ago, I can't see the full label of all the songs on my little soundboard thingy here on Zencaster. It just says taps. So that all I know is that they're just all taps. But I tried to make a couple different styles, and that one was intense.
Yeah, we'll call that one the M37 tap, because it's pretty intense.
There we go. I'm going to change things up and start with administrative details, because nothing keeps viewers around like going straight to administrative details. So for those of you that don't know, we are both a podcast and a YouTube podcast. If you're watching on YouTube, you can go listen to the podcast. If you're watching on the podcast or listening, you can go watch the video on YouTube. Just search for Taps and Patience and we should show up, or it's on the Audacity Micro channel if you're on YouTube. We have a Patreon, Taps and Patience, or patreon.com/Taps and Patience. We got a new Patreon. I'm trying to remember. Did we thank Zach for being new from Volunteer Machine Works? I don't remember if we thanked Zach from Volunteer Machine Works for being new.
I don't think we did.
So, okay, we have two new Patreons. Spoilers, one of them is Zach from Volunteer Machine Works. The other one is Jamie from JSpec Engineering, who's someone I talk to on Instagram all the time. Thank you, guys. We also have a couple of new free members. I still don't know what free members get, but people sign up for it, so thank you.
Nice.
So Renato and Ashton, thank you for signing up on the free tier. And then every episode, we thank all of our $10 a month Patreons. And those are now, as I said a second ago, Jamie from JSpec Engineering and Chris from Zajic Precision. Had to look that one up, sorry. Then we have EJ at Nocturnal Welding, Simon, Chris at Thought Bomb Design, and Jake Brownson. The reason I led with this is because we let Patreons ask questions of us. Most of the time they don't, even though we encourage them to, but this time they did. So Thank you, Patreons. Make sure you leave those. This time I actually did a post on the Patreon like, hey, what are your questions? I think that's the key to making people actually do it.
Okay.
So firstly, the easy one from Jamie. He asks, how are we managing and disposing of coolant?
Ooh, that is a good question. Well, I grew up on a farm, and the way you manage and dispose of liquids on a farm is you throw them outside. So, not the best answer.
EPA, close your ears.
Yeah. So, honestly, we haven't really disposed of a whole lot of coolant as of yet. Like, the most coolant we've ever dealt with has been small amounts, and that is something that we are in the process of figuring out because we're moving into more industrial spaces. This is no longer a garage shop where you can get away with stuff like that in small amounts. So that's something that we've got to get figured out that we don't have figured out yet.
So in my entire career, which as a machinist, which remember isn't really that long overall, I have only ever had to deal with a large amount of coolant once. And that was when the Tormach from my old day job was leaving. I've never changed out coolant on one of my machines. Like generally I just top it off and occasionally I'll like clean out the tank a little bit or something, but I've never really had to dispose of like 100 gallons of coolant. But at my day job, we had to get rid of like, I don't know, it was one Tormach tank full, just 10 gallons or something. Yeah. And we did the time tested method of dumping it in 5 gallon buckets and then forgetting about it for like 6 months until it was all evaporated down. Then we threw away the bucket. Really, in my current shop, my method is I put it in my machine. It eventually leaks out onto my floor. I mop the floor, and then I dump the mop water down the drain.
Yep, that's how 90% of mine ends up going away too.
Yeah. Other
So
than that, I just check the machine probably, I don't know, twice a week or something. I'll stick the little refractometer underneath the coolant stream and hold it up to the light and
yeah,
either add more coolant or not.
yeah. I was gonna say that like we've never really drained our machines ever.
What about the move? What'd you do on the move?
On the move, what did we do on the move?
Am I about
I
to get the
think
EPA called on you?
maybe no. We ended up vacuuming out a lot of it with shop vacs, and it was like a sludge. And I think we threw it away, like most of it, because it was like it was mostly sludge because it was also it had a bunch of crap in the bottom of it, and so like it all got mixed in and it turned into a semi-solid. And I think we got rid of most of it in trash bags.
On my old Tormach, I had really good filtration. And so I never really had that big of an issue with stuff on the bottom of the tank. I think it just got sucked up the coolant pump and then went into my filter, and I would just empty my filter like every
We
other
had
week.
we had a lot of plastic and aluminum that got in there, and those just got past the filter on the Tormach and just filled it up. And then the lathe, we had a whole bunch of steel and aluminum that were in the bottom of the tank on that one. So, and that one was only a 30-gallon tank, and the Tormach was, like you said, I think it was around. It's not. I don't think it's 10. I think it's like 8 or 6.
I think it's 10, but if you actually fill it up to 10, it overflows all the time. I
Yes.
think you have to run it at like 5 or
Well, if you have
you
a high pressure
overflow.
pump, you do, or a higher volume pump, for
Yeah,
sure.
that's true.
So that was our problem. Is we couldn't have more than probably 8 gallons maximum, maybe 7, somewhere in that range. Otherwise, you would just overflow constantly.
Yeah. Speaking of which, we need to get back around to the filter conversation because I have something there. But the other question we got from Jake Brownson is the most expensive mistakes we've ever made. I have a couple.
Ooh,
I'll go first while you think.
Okay.
So, I mean, we can go through all of mine. The most expensive mistake I ever made was not one that IA ended up paying for. It was one that went on to my employer. So we had a customer. It was a high volume customer. And this was a sheet metal shop, so we did some fairly high volume work for them. But when COVID was starting, they insisted that we buy a whole bunch of aluminum. They wanted, I think it was 3 coils of aluminum, which is like 21,000 pounds or something like that of aluminum. They insisted that we buy it at the current market prices. So, and the way our contract worked with them, it was materials was based on market rates. Because they would, give us a contract and like, hey, we want this many. And so they were worried about prices going up. And this was like before COVID was a big deal. Prices were starting to go up. We were like, prices are up, 30% or whatever from normal. This will blow over. This will come back down. And so I told my boss, it's like, why don't we just basically short them on this? Not like rob them, but like do a market short. And so he said, okay, yeah, sure. We'll sell you the aluminum at the high price. And then we were expecting the price to go down. And then the prices never went down.
Ooh.
So basically we sold it to them at a lower price. And then the prices went up on us and we had to fulfill buying materials at the higher prices.
Ouch.
So that was expensive. Sorry, Carrie. Sorry, Mr. Boss. That one did not directly bite me, but okay. I suppose that company is out of business now. So that was not why, though.
I'll do my most expensive mistake I've ever made personally, and then I'll do the one for my business. So,
okay.
In my business, I've been fortunate that I haven't had any big mistakes as of yet. Knocking on all the wood. But Before I started the business, and I don't know if I'd classify this as a mistake or my fault or how you do it, but I'll just give you the clip notes of it. Basically, we had a customer that had a project that came to us, and I was not involved in the bidding of said project, but I was the engineer that got handed the project when it was done. And there was a lot of feature creep. And I ended up building. So basically, what it was going to be a lift to raise up some product in a plant. And it was a hydraulic lift. In the beginning of the project, it was supposed to be 1,000 pounds in a one-way process where they load it on, it comes down, and then they take it off. By the end of the project, it was 2,000 pounds. They needed to load and unload it from both ends. And instead of loading and unloading it with forklifts, they were doing it with pallet jacks. And so they had to be able to bridge the gap. And it was supposed to be roughly a $20,000 project. And I had to go sit down with my boss. By the end of the project, we had built it 4 times and installed it 3 or 4 times. And I ran all the numbers, and we had 80 grand and sunk into this project, and the customer was pissed. And I thought I was going to lose my job. And so I basically went into the office of the owner of the company, and I said, "Listen, I explained everything that had gone on it. I told him everything that I did, and I was just like, listen, I don't know how I can make this thing work." There was the reason it failed, without going into too much detail, was basically the amount of features that they wanted this thing to have. There was no way to keep the load level. So normally if you have a scissor lift or something that you're trying to lift hydraulically, you need a way to connect the two sides together. But because they wanted to be able to drive stuff on and off, the only way you could connect the two sides was hydraulically. And so it was having a hard time keeping the cylinders timed if the load was off to one side. And they even brought in like an expert in hydraulics who did nothing and couldn't figure it out either. But anyways, long story short, the owner was very gracious to me and took everything that I said, because I wasn't trying to hide behind and say that it wasn't my fault. I tried to take all of the responsibility and said, "Listen, I will. If you have any criticism of me, I will take it. This is what's happened." And he responded incredibly well to that. And he ended up handing it off to a team of 4 or 5 different designers after me, and they never finished that project or made anything better than what I had made to the best of my knowledge. And so that was the biggest mistake of my life, or of my engineering career. And that one sucked and was very stressful. But ultimately had a happy ending, even though it didn't cost me anything. It cost the company a lot. So there's that. And then inside the business, the biggest mistakes that I have had, I'm actually, I think, dealing with that today. I've actually, I think, had the most money lost today on a job. And basically, I've been trying to use some 3/4 and 1/2 inch end mills on some stainless, and they're about $200 to $300 a pop per end mill, and I've trashed like 3 or 4, and I've never had that happen with something that big or expensive, and so it's been very, very painful. And we can talk about this a little bit more, because I was going to anyways, to some extent, because what I have learned through this endeavor so far is that a 1/2 inch or even a 3/8 inch end mill, once I slowed down the larger tools to a point where they were not breaking, the 3/4 or the 3/8 and 1/2 inch end mills are about the same material removal rate by the time I've slowed down the bigger ones to where they're not breaking. So I'm trying to figure out what to do there.
Yeah,
And
that happens. Sorry, that happens on materials where you are surface speed limited, I find.
so
But
go ahead.
I
Yeah.
was thinking, like materials like stainless, titanium, sometimes going up to a bigger tool doesn't actually make that big of a difference.
Mm-hmm.
Especially
Well, For this one specifically, what I'm trying to do, it's a part. It's probably a 4 or 5 inches long by 3 inches, or 4 or 5 inches long by about 2.5 inches wide semicircle, and I'm trying to take about just under a quarter of inch, or maybe 3/16 of an inch of material off the top of it,
Mm-hmm.
and I've gotten it down to where I can take it off in about a minute, and that just destroys tooling. And I've tried it with a face mill, and it destroys the inserts. I've tried it with a 1 inch and a 3/4 inch end mill, and those both got destroyed. And the fastest or the most consistent so far has been with a 1/2 inch end mill, and it's taking me about 2.5 minutes. And I had it up to about a minute and a half, but it would only last for about 5 or 6 parts, and then it would get destroyed. So a little bit of backstory on this: I have to run about 50 parts, and we pre-bid the job based on me getting them done in a certain amount of time.
Mm-hmm.
And so I've already blown past our budget in terms of breaking tools and in terms of time, because I've lost a lot of time today. But I've been fighting this to try to figure this out, because this machine definitely has the horsepower, but I can't figure out why. One, this is a perfect job for a face mill to just go in and take off that material. But the amount of time I have to, or the amount that I have to slow it down to where it's not destroying inserts, means that facing all of it off on this particular part would take like 5 or 6 minutes. And at that point, end mills are faster to adaptive it off, and then just come in with the face mill and kiss it to add the final finish.
So at this point, is it still just a block? Like it's a
This is op 2, removing the hat.
okay. Is that where you're running into issues? Like the hat bends up or something?
No, I use a 3/8 end mill to remove any of the
Okay.
overhanging stock, and then I'm just decking off the once I've removed everything that could be dangerous to an end mill, or to anything that's decking off the material. That's when I've come in with the face mill.
So what is
Or
it that's killing tools?
they're just getting chipping. I'm just having to slow my surface footage way down.
Hmm.
And so this is something that I'm really struggling with, because I love the helical feeds and speeds. I've mentioned this before. I'm using a 3/8 inch 5 flute from Haas, running helical feeds and speeds. And on this 5 flute end mill, I have about 5 or 6 hours in the cut, and the end mill's still going strong. Okay. And I'm using that end mill to walk around, because this is a laser cut piece. I'm using this end mill to take off the scaling around the outside and taking out the perimeter. And then when I flip it over on the other side, I'm using it to remove everything that's overhanging on the stock. Okay.
Mm-hmm.
And it's actually running at, in stainless 304, it's running at around 500 to 600 SFM. And like,
Which is high.
which is very high. And it's 500 to 600 SFM. It's running at like 6 thou feet per tooth, and it's stepping over, I want to say, 30 to 40 thou, somewhere in that range. And so it's really fast, and I like seeing it in stainless. It blows my mind that it can move that fast. But it's got 5 hours running at those feeds and speeds so far,
Mm-hmm.
and it's been fine. And I've run 2 or 3 in those like that, and I've been able to get. This is the first one that I'm actually clocking. But on that tool number, I have about 30 or 40 hours of total cut time, and I think I've run less than 5 tools through it. And I've had a couple tools break because of dumb mistakes. So I'm know I'm getting pretty good tool life out of those for stainless, for that high of surface footage. And on that facing of the top where tools are breaking, I'm down around 400, 300, sometimes 200, and tools are just getting destroyed. And so I don't know how I can be up at 600 on my 3/8 inch, and it's running like a top. It's just banging out parts left, right, and I don't have to worry about anything. But then when I go to remove the material off the top of the part, the recommended feeds and speeds, I've used Haas recommended feeds and speeds. I've used Helical's recommended feeds and speeds. I've looked at Kennametal recommended feeds and speeds, and I've been comparing all these different tables and trying to run them at different things, and I keep having to slow them way down to the like. I keep having to slow them way down before they stop breaking things, and I don't know why.
So you're not on the trunnion for this, right?
No, this is two vices. This is vice work. I got op 1 and vice 1, op 2 and vice 2, and it's done.
Is there any vibration or movement in the part? Are you like overhanging the vise at all, or
I
anything
got
funky
soft
going on?
jaws, and in op 1, I have no problems, and I'm holding on to it by 80 thou with some like talon grip type jaws. And then in op 2, I have soft jaws, and I would say 80 to 90% of the part is in contact with the soft jaws on the bottom surface and along the whole perimeter of the part. And it's rock solid in there.
Okay.
I don't hear any like chatter, vibration, like noises. Like if you do like the tap test on the top of it, it sounds solid.
Interesting. Just trying to think of what could cause it. Is coolant access any different?
No, you got flood coolant, and for some tools I've got through coolant, and I've got them both going at the same time.
Could the material condition be any different? Like if
That's
one side is hitting laser cut stuff or one side's been rolled or something?
So all the laser cut work is done by the other tool, the 3/8. There's nothing laser cut whenever I'm coming to remove in the scaling off the top. And I don't have the issue with the scaling on the top on op 1, but I'm only taking off, instead of taking off 3/16, I'm taking off, I think, like an 1/8 inch or less. Maybe 80 thou off the top of op 1.
Hmm.
So it's definitely less of a load in op 1 for taking off the top, but it's op 2 that's killing them. So, and I don't know why.
Yeah, so
So
nothing's jumping out at me.
no, and I think it's just a surface footage thing. I think ultimately, like I just got to slow things down. But I don't understand why all of the calculators for 304 stainless steel, I'm having to slow it down much lower than what I normally would. Weston's theory is we got this material from Send laser cut. That way, because it's a half circle, it's got a lot of material taken out, and there's some big holes in the center, and it's got those punched through where I can just take an end mill in, drop it in, and interpolate it out.
Mhm.
And in this case, for this job, ordering material through Send laser cut blanks to reduce machining time, it was just as cheap as buying a stick and cutting it up, or close to it, close enough to it that it paid for itself, versus buying material and saw cutting it and going from raw. And so Weston thinks that the laser cut material that Send has is just it's not annealed, or it's hardened in some way, which I could and he said, maybe some of that's from the laser, like everyone else has been saying, but I'm eating through all the laser scaling on the outside with that other tool, and we're talking about the top of the part that has no laser that's been hitting it.
Yeah, I can't think. I mean, a cold rolled sheet would be harder than
Hot rolled.
like a bar. I'm still almost wondering if it's like moving funny on you as it cuts, or like something about the shape of it is putting like a burr that your tool is coming around and hitting or something. It could just be the hardness from it being rolled. There is a significant difference, but
Yeah. That's probably what it is. I just don't want to hear that answer, and I want to hear a better way to do it. So, regardless of what the answer or the solution actually is, the light at the end of the tunnel for this problem is that I'm going to the Titans of CNC Boombastic event this week, and
ooh.
I'm going to ask Mr. Titan himself what he would do in this situation. Because
Well, he would not tell you what I'm about to tell you, which is slow is smooth and smooth is fast. Because if you
yeah,
had just slowed it down, you would have been farther along now than breaking all these tools.
yes and no. So I've if I slow my feeds and speeds down, I got the same amount of parts done that I would have had I been at the slower feeds and speeds. Because my machine,
So you would have been in the same place with less broken tools.
yes, but I'd be way behind in what we bid this job at, and I would be further behind for all future jobs if I run into the situation again. There is a way to remove material faster off. Okay, basically, I'm back down to Tormach feeds and speeds on my new machine. I should be able to machine this faster on a bigger machine. Like if I can hold bigger
Yeah.
tooling and I have more power, there's got to be a way to remove this material faster, some way somehow. Whether it's a face mill, whether it's a larger end mill. Like there's got to be some way that I can eat that material off without destroying things at a faster rate than what I can do with a 1/4 inch tool on my Tormach. Otherwise, I'm going
Yeah.
backwards.
I mean, sometimes the material wants what the material wants. And, it's kind of like, are you shooting a hole through a piece of paper with a 9mm or like a Colt 45? Like at some point, the material gets to choose what the material chooses. It doesn't matter how much power you have behind your spindle.
No, it doesn't matter. But what matters is what tool I could throw at it. I could throw a 5-inch face mill at this thing if the inserts would
Yeah.
handle it. And so I don't understand why I have to slow down the surface footage to a point where it's so low that it's not gaining me anything. Like, what's the point of having all this power and being able to throw all these different types of tools at the same problem if they all net you the exact same time?
Yeah, but like the material doesn't care about your cycle times.
No, it doesn't. It's really annoying.
Um, what do I run stainless at? Of course, I pulled up a plastic part. I feel like I run mine way slower because I don't care about cycle times.
Yeah. Well, to put it into perspective, if I got 15 minutes apart, which is what we had quoted on this job, then I would have the parts done in about 2 days. As it stands, if I have to slow everything down, it's going to take me 4 days to get all these parts done. And I'm going to be up a creek because I'm going to be gone 2 days this week because of that event. And Weston's out all this week because he's having another kid. And I have parts that are due on Monday that I really need to get to, but I need to get these parts done before I jump over to those parts. So that's part of the reason I'm pushing it as hard as I am, is because I am in a time constrained scenario where it's not just Harrison wants to go fast. That's part of it. But the other part of it is that if the material was different, I'm sure, like if it was 303, I could probably get these parts done in 10 minutes.
Mm-hmm.
More or less. It's just, I don't know what it is about these parts where if the material is hard, is there not a machinist trick that's out there? I mean, if you told me it was possible to run an end mill in stainless at 600 SFM before I got this machine, I would have said that that's dumb and your tool's not going to last. But I've been running my 3/8 tooling like that basically ever since I've gotten the machine and started plugging in helicals, feeds, and speeds, and my tool life has increased compared to what I was getting on my Tormach. Part of that's rigidity and a bunch of other stuff. But regardless, I'm still getting insane tool life for those feeds and speeds, and that's just an ER call at holders. I think it'll be even better once I go up to something like a power grip or shrink fit or hydraulic holders. And even if I get my speeds and feeds dialed in a little bit better, 600 might be a little crazy, but maybe I drop it down to 550 or 500, and I'm still, my tool life jumps to 30 or 40 hours a tool, but at a little bit less cycle time. Who cares at that point? Like I'm figuring all this stuff out right now. I'm figuring out how far I can push things, and then I can dial them back to reasonable values. But I feel like I should be able to go a little bit faster than what I am in this situation.
What toolpath are you using?
Adaptive.
Okay. Have you tried a traditional toolpath, like a facing or a pocket?
Yes.
Or clearing, I guess they call it when it's not a pocket.
Yeah.
Have you
It
tried a
has
high feed strategy?
that I haven't tried. I haven't tried. Like, are you talking about where like you have a really shallow cut going really fast,
Yeah.
like a
Low
high
depth
feed
of cut,
mill?
high feed,
Yeah, I
which works
have.
with normal end mills.
Oh, it does. I
Not
thought you
as
had to have
well,
this.
but it's still a viable strategy, yes. A bull nose is better if you have a bull nose.
Yeah, we have. That's what we've been running with is bullnose. I do have some high feed end mills that I got a long time ago. I tried them in the Tormach and had great success and horrible failures, and so I stopped using them. And so, right, small success with great failures. Maybe that's a better way to put it. And so, I got a couple of those that I could throw in there and just see how they do. And that's kind of what I was leaning towards today. And I was looking up, how big of a high feed end mill could I get to make sense for this type of application? Because this is not the first time this problem has come up. It seems like I destroy most of my tooling in this situation, where
Hmm.
it's a thin surface that I'm trying to deck off, and I was thinking face mills would be my solution, and it just tears up face mills, and I don't know why. And like I called the Kindle Metal rep and I had him on the phone, and we have one of their super slick face mills that's a 2.5 inch 45-degree face mill, 6 inserts with their state of the art cutter. Oh yeah, it should be able to run 600 SFM, no problem. Okay, destroying inserts. And these are the octagon ones that have 8 sides, and then you flip them over. So there's 16 total. And so he said, just drop it down by 50. He said you should never get below 350, whenever it starts working. And so we did. We would run it, and then it would tear out inserts. We'd rotate it, slow it down by 50. Run it, tear up some inserts, rotate it, slow it down by 50. And by the time we got done, we were down around 200 SFN before the inserts would last for any length of time, using the recommended speeds and feeds and chip load and all that stuff. And so I don't know what we're doing wrong. It's just really, really frustrating.
I looked. I run stainless. I run 304 at 200 SFM.
Yeah. And
But
so,
again, this is a mentality difference between you. I have no problem. Like what I once that's running reliably, that's all I care about. I have no problem sitting next to my machine, like put my shoes up on the workbench and like watch a YouTube video as the machine runs. I don't
mm-hmm.
really care how long it takes. I have no problem doing that. Your work is a little bit different than
Yeah.
mine.
Well, it's a lot bigger, it's a lot higher volume, and I'll get big POs with a couple hundred parts, and I got to get them done by a certain date.
I
And
bet sometime this year you will or have gotten a PO that is more parts than I will run all year.
oh yeah, I've already run. I had one PO with 5,000 parts, so
Yeah, that's more parts than I'm going to run this year. Like, I got a job of 100 parts the other day, and I was like, wow, this is so many.
yeah. Now,
They
granted, those
fit
were
in a
lathe
bin that
parts.
was this big on my table.
Yeah. Granted, the 5,000 that I did, that was 5,000 pins, and so I mean it's a little different for that because you just set it up. The machine, the lathe ran for 2 weeks on that. Yeah, it was a lot,
Wow. Yeah.
but
I did all of my 100 parts in, I think, 4 hours.
yeah, we were doing
And that was long for me.
the pins were running. I think one pin was running at about 40 seconds. We'll call it 45 seconds just for fun. Yeah, so that was
Okay.
62 hours or 63 hours of straight running, not including changeover, rotating inserts, loading bars.
Yeah.
That was 62 hours of just straight the lathes running. So, but anyways, so whenever you get into those types of workloads, which is what I've been trying to prepare for as much as I can, if you're running 5,000 parts,
A second on each one makes a big difference. Yeah.
a second on a part is an hour and a half. Every second saved on that job is an hour and a half of less machining that you have to do.
On 5,000 parts?
Yeah.
Okay. Yeah.
So if you do 5,000 divided by 60, that's going to give you your minutes, and it's 83 minutes. So that's about an hour and a half. So, anyways.
But I don't know. There's a lot to be said for having a reliable process that just works as well. Because like one broken tool, like yes, okay, it may take 4 minutes to swap out a new tool and get the program started again.
Mm-hmm.
But then you're also like trying to figure out why the tool broke, and maybe it's your last tool, or maybe you're going to run out of tools, and like that whole process. I mean, sometimes one broken tool can be like a day, or at least an
Okay.
hour or two as you figure out what's going on.
So if I slow this down to 200 SFM, we'll just use the hypothetical for that. And I did the numbers on this. I go from 15 minutes apart to 35 minutes apart because it takes 20 minutes to face this at 200 inches a minute.
Mm-hmm.
That's 20 minutes to face it versus 15 minutes to run the whole part how I have been doing it, even though I have been breaking some tooling in the process. But the tooling's been surviving for 4 or 5 parts before it breaks. So like it's not like it's immediate implosion on the parts. It's just figuring out, and like as I slow things down, they last longer. And so I'm trying to figure out the tooling and the strategy because I know it can happen. And at some point, I'm just going to throw the 3/8 inch tool that's been successful so far and just adapt away with that because I know that tool's reliable and it's in the 2.5 minute range to face off both sides. And so it's plenty fast for this application. If I wanted reliability, I'm just going to throw that tool at it. But I'm frustrated that none of the other tooling options that I have can beat that because I'm going through an adventure of trying out all of these latest and greatest tools from all these big manufacturers, and none of them are beating the 5 flute end mill from Haas. Okay, that's a problem.
What step over are you using for your adaptive?
I mean, take your pick. I've used everything from 20 thou to 1 inch.
1 inch on an adaptive?
Yeah,
With the face mill?
with well, it was 90 thou, and it was with a 1 inch end mill. So
Okay.
it's basically slotting. So I talked to one of my local machine
900
shops.
thou.
Yeah, 900 thou.
Okay.
It was. I talked to one of my local machine shops and I asked him, "Hey, you guys run massive tooling. What do you do?" And he basically quoted me the slotting feeds and speed recipe. And I'm like, "That's what you do?" And he's like, "Yeah." Okay, we'll give it a shot. So I tried that. It didn't last.
You take a drill and you peck away all of the.
Yeah.
You
So
left your go
anyways,
drills.
yeah,
They're
I
your
do love
favorite
my go
tool.
drills. They are. They just work. I need a go drill
Well,
end
here
mill.
you go.
A
So
go
there's
end mill.
no, but like when you're doing this part, there's no like hat or anything that's getting like wrapped. Like there's no little thin layers that it can pop up.
No. I take care of
That's
all of
so
that with a
weird.
3/8.
I don't know. I feel like you've already tried everything that I would try, other than just running it slowly and like
Yeah.
buying a cot.
Yeah. So
A cot is only one of those end mills, pretty much.
yeah. So
It might be the most economical option.
yeah. Well, it's like I said, it's one of those things where I the only reason I am frustrated at it is because I don't like thinking that I don't like accepting the status quo without pushing the boundary. And
Mm-hmm.
I don't have any formal machining training. I'll admit that. I don't have um, a lot of industry experience. I'm still very new to all this. I got my first Haas mill, and to everyone else, it might be a piece of crap, but it's my baby. And the only reason that we've survived as long as we have is because I'm pushing the envelope with everything I do. And while this is frustrating to me today, I will come up with a solution and I will be machining it faster. It's just what is it going to take to get there? And that's the only reason I was able to be competitive with the Tormach was because of that mindset. There's no way that I could be competing with those guys at the company that I'm doing most of my work for with the Tormach if I didn't have this mindset. And now that I got a bigger machine, I'm trying to take the mindset I had with the Tormach and apply it to this machine. That's the only reason I'm getting as frustrated as I am over something stupid that, yes, could be solved with just taking your time and slowing down. That's not how I've grown this business, is taking my time and slowing down. That's never grown the business thus far.
Fair. The next thing I would try would be a bullnose end mill or a high feed mill doing a high feed strategy.
Yeah, that's probably the direction I'm going to go. So I'll have to give that a shot.
The only other thing I could think of, and I have no idea why this would help, but if you use the slot clearing method on the adaptive toolpath.
That's basically what I did whenever I did the 900,000 step over. It was basically slotting.
Okay, no, slot clearing is it will come like, okay, let's say you were facing off a block of material like my phone here. Instead of it coming in from the outside and going around, it'll ramp like down in the middle and like make a slot and then go out from there.
Oh, I see what you're saying.
I don't really know why it exists, but
I've used that
different
once.
than what you're doing.
I've used that once. Yeah, I think it's the scale on the top that's causing the issue more than anything. It's just breaking through that scale is destroying tooling.
What if you came in with like a roughing tool, skimmed off 10 thou or a little bit more, and then came back with a better tool once that scale was gone?
Yeah, it might could.
What's your mode of failure? Is it broken tools or ugly finishes?
Chipped corners.
Okay. Yeah, so just do a rougher and a finisher.
So
sacrifice a mill to be a zombie mill and then come back with a finisher.
I'm basically already doing that. And the machine gets really loud when that zombie mill starts going. But I'm trying to find a better way. Because yes, I am using a rougher and a finisher in the sense that you're saying. But I wish I'd taken some photos of that end mill. It destroys them pretty bad. It takes out those corners hard. To the point where
it's cutting. End mills can look like hell and still cut.
Yes, they can, but whenever they look like hell like that, they leave pieces behind that your finisher hits. So
I suppose that's a possibility. I've never seen that happen. But
well, I mean, whenever your end mill starts off at a 1 inch and it ends at about a 5/8 of an inch diameter,
it's for the most part, unless you're doing a bore, it's fine.
It leaves stuff behind. And all your whenever you finally do stop and take a look at it, and only one flute is doing 90% of the work because all the rest are gone, it's time to replace that one.
My 4 flute that I have right now in my mill, or my 4 flute 3/16, which is my big roughing tool.
There are weird.
I do have a 3/16 inch finisher though.
There are weird occasions where your tool breaks and starts cutting better. Because I've had that happen a couple times.
I've never had it cut better, but
so I had a tool that I got. It was a tool for cutting threads on the lathe, and it chipped off and created more clearance on the backside and started cutting better. And so it was still cutting the same thread profile. It the thread profile existed in the exact same, you couldn't tell looking at the face of it that it had broken.
Yeah.
And it chipped on the backside and it created more clearance and it cut better. That insert lasted the longest. It's kind of wild. So, but anyways, that's my venting for today on the podcast and to all the listeners who I've been shouting at. So, yeah, As you can see, I'm quite passionate.
Yeah. I'm trying to remember what I've done over the last week. I had the job that was the 100 plastic parts, and that went really smoothly. It took a little bit longer than Fusion was predicting because it was all Delrin, and it basically was more linking moves and travel moves than it was actually cutting.
Mm-hmm.
Because when you have a 40k RPM spindle and you're running Delrin, you can cut really fast.
Mm-hmm.
And I did so. So it basically became all linking moves because there was very little roughing. It was doing most of the stuff in one pass and then coming back with a finishing pass. All the roughing in one pass and then finishing is a separate pass. And those just ran pretty much without problems. The first ones I was running the roughing tool passes a little too fast, and the Haas control will adjust corner rounding based on your speed unless you otherwise confine it. And it was corner rounding too much and making my parts too small. So I had to back that off a little bit and adjust the G187, I think it is, which slowed it down some, which was disappointing because it was really cool and it was running at 400 inches a minute.
Yeah.
But I had to slow it down to like 200 or something. Otherwise, it would choke on the code and or not be able to make the corners.
Have you? Can your machine rapid faster than it can cut? I think most houses are that way.
Can it I think theoretically.
Because my machine, it can only cut at 800 inches a minute, but it can rapid at 1400 inches a minute.
Mm-hmm.
I heard a story of a guy who changed all of his cutting moves to rapid moves in plastic.
Oh gosh.
So he could cut at full rapid, basically, for one of the parts he was doing. Because it was as fast as he could go.
Yeah.
Just throwing at it. It's just like, oh my goodness, that's crazy.
I did not get to do it the fun way that I was hoping, which was using the key seat cutter to do it as a one and done. I ended up when I really got down to it, yes, that would have been cool, but it worked out better to do it in 2 ops in my flux vise. So I had two ops, each with 2 stations just on that vise.
Yeah.
And the cycle time was, well, Fusion said it was going to be like 1:45. It definitely was not 1:45. I timed it to be closer to 4.5 minutes.
Yeah.
But they got me 2 complete parts each cycle. I think my first 2 were off because of that thing, and then every other part came out good. So
yeah,
that was nice. I ran some simple parts other than that, like a block with holes, a cylinder. I'm looking back through Xometry, some super glue workholding stuff. I did the cube stands for the cube Kickstarter. Those I need to get done for a long time. I did some orange slices for Scott. I need to do more of those. I published a video on the super glue workholding, which you don't use super glue workholding, do you?
I have. I
You
don't
have?
do it.
Okay.
I don't do it often, but I'll do it every once in a while.
So that video did not get very many views, and it's kind of disappointing because I thought that was a good video. But if you want like the definitive super glue workholding method, like this is kind of what everybody agrees is the best process at this point. The one improvement that you can make that I did not cover in the video is a lot of like watchmakers who use this method. They'll cut grooves into their fixture, into their pallet. But everything else, like, we've pretty much nailed down at this point the best glue you can use, the best surface prep, the best tape if you're going to use tape. I recommend not using tape. So if anybody wants the definitive guide to super glue workholding, at least as of right now that is on YouTube, I don't think there's a better guide. Toot toot. It's just me tuning my own horn.
Yep.
Go watch that video. It did not get very many views, but I think it'll get a lot of views in the long run.
Yeah, that I need to finish watching. I've watched about half of that one. So
okay.
I was looking through my jobs that I did since we've talked last, and I forgot that we did in my frustration of today, I forgot that we've done the largest part that we've ever machined to date.
That big plate part?
Yeah, we did a big plate part for Xometry, and it was 16 and a half by 16 and a half by a half inch thick. And
Part.
it was a big part. And I found out because I'm kind of mad at Haas for this. Because Haas sells, it does not make their stuff. They resell vices and things. We had bought a vice from Haas on the
Mm-hmm.
Tormach, a 6-inch vice. And then when we bought our new machine, it came with a tooling package that came with a 6-inch vice, but it was at a different height. And so we had two different vices at two different heights, and I had to do a part that was the longest part we've ever done on that machine, and it was like 21 inches long. And I had to span it across both vices to make it work. And I ended up putting in a set of soft jaws and cutting them at the same height, and that's how I did that part. It was thin and long. And so that worked great for that part. We realized that if we ever wanted to do a big plate and I needed to open up the jaws and lay it on top of the vices, that I needed to
Mm-hmm.
get a matched set of vices. And so we went on to Haas's website and we ordered the same vice that we had ordered the first time, not the one that came with the machine, but what we had ordered the first time, and it was a different vice. Haas had changed it
Mm.
out. And so we now have 3 different vices, and
None of which are the same height.
none of which, so the new vice that came actually matches within a thou of the height of the first one, or of the second
Okay.
one, that we got that came with the machine. So that was kind of good. But my next problem is this. So it matches the same on the base of the vice, but the thickness of the, whenever you take the back jaw and you can move your jaws on front or behind it, the thicknesses are different.
Mm.
And so you can indicate them in on the front whenever your jaws are in the front or when they're in the back, but not at the same time, because they're different thicknesses there. And the tops of the jaw of the vices used to be at different heights, but because of this job, I planed the top of my vices down to be a match set.
Yeah.
so so now the tops of the vices on tops of the jaws, or on the top surface on them, is the same height. The the bottom surface is the same height, and they're aligned on when the jaws are on the front. On the back, I have a solution for that. I just haven't taken the time to machine it. Basically, I'm gonna make my own match set out of these eventually,
Yeah.
where they're the same on everywhere. But anyways, that was a lesson learned, and we ended up making, because the reason we had to do that was that part had a 5 thou parallelism call out.
Across
And
a big part.
yeah, and so I had to have everything on the same plane, and I couldn't just use a set of soft jaws, because then it would be 16 inches, or almost 17 inches, just being held up on the ends, and that thing would have been a giant spring,
Yep.
and would have chattered like a crazy. So I had to have it down on the tops of those vices where it only had like the middle portion that was unsupported. And thankfully, I didn't get any chatter on that job from facing it.
Nice.
And I used that same Kennametal face mill that I was complaining about, the 45-degree cutter. We got some aluminum cutting inserts for it, and it's my favorite face mill for aluminum. So it just destroys aluminum. I wish it did that for stainless, but for aluminum, at least it destroys. So
And stainless material destroy you.
yeah, so that's all right. I'll get this figured out, or someone will say something that'll inspire me to think of something that I haven't thought of yet. Um, like it usually happens. This is not a new cycle for me. I have gone through this cycle many times over my machining career, and many times in other things outside of machining. I'll get fixated on a problem. I'll eventually come up with a solution, and then I'll never think about it for the rest of my life. So, this is a pattern, and this is part of growing. If you're not fighting something, you're not growing and you're not learning.
Yep.
and so I have mini fights every day. That's how I justify it. But no, it's a lot of fun, and I'm excited for going down to Titans this at the end of the week and um, kind of meeting some people down there and probing the most hated machinist on the internet with some questions.
Yep, I'm jealous. That sounds like fun.
But we'll see how it goes. So yeah, that's about all I got. You got anything else?
Yeah, I know I did stuff over this last week, but I'm having a hard time nailing down what. I think it was mostly because it was like some design the everything stuff. Did I talk about the carabiners?
No, you did
That's
not.
what I did. Okay. It took me 2 years, but I have finally nailed down how to make carabiners.
Nice.
Oh gosh, that was a process. But I have a fixture now. The fixture just holds three carabiners for the it's really 2.5 ops. It used to be op one was split into 2 halves, where halfway through you'd put your screws in. Now I have changed it so that half op gets its own station. And so every time you hit go, you get a completed carabiner off of the fixture, and you just move everything over one spot. For the first op, I'm starting with water jet cut blanks from Fidget Things, and the first op I like profile the outside. I profile the outside and do some and I do the slots through it. And then it moves over into the second op station where I machine off the top of it and machine out like the inside contour and like release that slug. And then in the third op, it's basically just backside chamfers. And that's held with some custom made cam clamps.
Backside
So
chamfers. Is that
yeah, I'm just flipping the part and chamfering the other side.
Oh, okay.
So they're front side chamfers. I'm not machining them from the back.
So when you cut the first side, you don't chamfer anything, so you have more holding area.
So no. I chamfer the top and then I flip it and I chamfer the bottom. Actually, I fillet everything now. By the way, I changed the whole design to fillets.
Okay.
It is no longer chamfers, but
how big are your fillets?
They're not huge. They're like 20 thou or something.
Oh, okay. Are you like interpolating them, or do you have an actual fillet tool? Okay.
16th inch ball mill at 30,000 RPM. It does pretty well.
Okay.
I do have a little bit of time that I can take off of it. Right now, it's running about 45 minutes per finished carabiner, which is actually about what I was getting off the Tormach. Except now I haven't scrapped a single carabiner with the new fixture.
Oh, that's good.
Except there is one tool path where it was like 2 a.m. when I was finishing it up, and basically I was just lazy. And I could turn right now. This one tool path is doing like 5,000 step downs because I was too lazy to do a roughing tool path, and it takes like 10 minutes. If I add probably a 10-second roughing tool path, it'll make my 10-minute tool path into a 3-minute tool path, and that tool path happens twice. So,
oh wow,
it'll immediately save me like 20 minutes. I just haven't gotten around to doing that.
So you thought you'd run 40 of them before you speed it up by 20 minutes apart?
Yeah, pretty much.
You're like the opposite of me.
I know.
I will spend 10 hours to save 5 minutes apart, and you will run 40 parts at like 3 times the amount of time they need to be before you go like, I'll change it.
So, okay, this is the beauty of this fixture. And this is the big thing that I wanted to like get to on this fixture. It is like a couple screws to bolt it to my table. It's the same work coordinate system and stuff every time. And the first operation is a probing operation to confirm just in case something got a little bit moved. I can set it up all offline off the machine. But that means like if I need to program something, I go put this on the fixture or I put this on the table. I hit go. I walk away. I come back to a finished carabiner later. the last thing I do, I load this fixture up, I hit go. Or last thing I do at night, I load the fixture up, I hit go, and I come back. So like I am never just sitting there just like running apart. It is like it just gets shoved in here and there.
That's the best way to do that, honestly. Just to keep your
Yeah.
machine running.
I was listening to Jay Pearson's podcast, and he made just this like off the cuff remark, like, like not the main topic, but he just like mentioned that like, oh yeah, a lot of people who use my pallet system will have a pallet that's designed to run overnight, and they'll have one product that like they just load up, hit go, and then leave, and it'll be very safe, very slow, but it doesn't matter because it's just getting them, a little bit of runtime overnight. And I was like, oh yeah, it's kind of what I want this to be.
Yeah.
So,
and I think Saunders has also mentioned something along the same line of he programs parts to where he has or he's at least talked about it, where he'll have a product or a part or something that he runs, and then he'll have the exact same program for it, just at like 20% or 30% reduced speeds and feeds. Just that way it's, bulletproof and not going to have any problems, and that he can run it overnight. And, the irony with all this is our goal is to get to fully automated where we can walk away. And when that happens, I could run things at 200 SFM and it doesn't matter, for stainless or whatever I'm doing. Like at that point, when you get into the automated world, you can get away. Like, yes, time matters, but you have more hours that you can use in a given day. So it doesn't matter as much as it does if you're just there for 8 hours or however long. It's just that we have this machine is our moneymaker, and I can't let it sit. I got too much work. I got to try to push through it, which is why the Tormach's for sale. FYI, anyone who's interested. And we want to replace it with like a VF2 size machine. So
I think it's smart. I spent like every method. I looked at all the different ways that I could get a 5-axis machine for my next machine, at least looking at new machines.
Mm-hmm.
And basically everything I came across was like the cheapest you can possibly do is a Haas something or rather with a trunnion. It doesn't really matter if you go CM or like a mini mill or like a VF2. They basically all work out to be the same price, give or take.
Mm-hmm.
Yeah. We did. So I was talking to the guys on the Instant Machinist Discord, and we figured out that I could probably put a door in the end of my building, like a new garage door on the end instead of on the side. And that would get me at least another 6 inches, which would be enough to get a VF2 sized machine in here, I think.
Oh, yeah. That'd be nice.
Or at least a Speedio sized machine. I don't actually know how tall VF2s are. But
they're pretty short, actually, compared to like, at least my machine is huge compared to a VF2. Because I've seen one of those in person, and it seems almost comically smaller compared to this one.
Because right now the opening to my shop is like 76 inches, I think. And if that goes up to 80 inches, the amount of machines I can fit in here like skyrocket. Once they're in here, they're fine. Like, I do have a relatively low ceiling, but there's plenty of room between joists if I needed to like build a box. But even still, my relatively low ceiling, I think it's exactly 8 feet, which most machines that are not larger than a VF2 can do fine with 8-foot ceilings.
Yeah.
So, but if I put a door on the end of it, okay, so here's the math. If I went anything bigger, I would have to go rent another shop. This shop, I don't pay anything for other than it's part of my mortgage. Actually, having this shop here saves me a ton of money on my mortgage because I get to write off a significant portion of the square footage. I also get to write off a significant portion of our electricity. We don't write off heat because this is electrically heated and not propane. But
yeah, in the end,
I actually get a lot of deductions because of being here. But even if that aside, so anywhere I rent, it's going to be at least, let's say, $1,000 a month. Real estate around here is pretty cheap. It's also kind of crappy. But I could probably find somewhere to rent that's cheap and nice enough for $1,000 a month. okay, I can put a garage door in the side. Let's say it costs $10,000, but I get to stay here for an extra 2 years.
Yeah.
Like that immediately, within a year pays for itself. And it
Mm-hmm.
probably won't be $10,000 to put a garage door in on the side,
No, it
an
won't be
overhead
that.
door. I mean, so
Especially
it
if it's
doesn't
not
even have to
powered.
be a door; it just has to be a removable panel.
Yeah. You just need a barn door. Just make it a big barn door.
Yeah, pretty much.
That's all you need.
So
A fold up wall.
I don't know. I still need, I think, another machine in here that does fit before I do that to kind of justify it. But um, after that, maybe I'll pave a section out on the end of the building and then put a door in.
Yeah. Yeah. That'd be good. You'd need another machine in there.
Yeah, which I don't know. I would still like something to complement the OM, something like a mini mill
How's that probe life?
with the Renishaw probe. I love that thing. It is one thing that's interesting is I used to have like a whole bunch of work coordinate systems like preset,
Mm-hmm.
and I find I just don't use those anymore. I just probe everything.
Mm-hmm.
I just do everything off of G54, which I probably could have some time savings if I used Fusion's ability to like I could still work in G54, but I could, like, let's say, use the corner of my vise as a reference to probe based off of to find the material.
So that's what we did with ours, and that's something I got to go reset all those points because I've moved all my vices around. But we basically have 1 point on all of our vices that's set up, and then 2 points that are set up, the machining point and then the probing point, and then basically from there, which I guess you technically only need one because you can reprobe everything in. But anyways, regardless of that, we have one location on every vice that I can just basically throw a part on there and get it close, and it'll probe in and go from there.
Mm-hmm. Yep.
And it's awesome.
So I think that's what I need to shift to. I do have a little bit of an issue that I've ran into where I think it's a limitation of how the macros are currently limited, or maybe my post is handling it weird. But it throws an error if I try to probe a work coordinate system that is higher than G59.
That is weird.
If I go to, I don't remember what it's like G. Well, on the
G
Tormach it was G. Is it G154?
150 war 4.1.2.3.
Yeah, it doesn't do that. So I don't know if that's the macros or the post, but something is not happy with that.
Do you, when you post your programs, do you load in your machine? Like, do you load in your machine into your setup?
No.
Okay. When you load your machine into your setup, at least with the Haas controller, or with the Haas machine that I've got, the VF3, it'll show up the extended, it'll give you a little drop down for your numbers, and you can do the standard ones or you can do the extended ones. And then that's when it gives you the P values. And that's how I've gotten it to work.
I mean, it'll like if I post code to, G18 or not 184, but I don't know. If I post code to the extended offset, it works fine. If I try to probe an extended offset, it fails at the probe macro. And I haven't looked in to see if it's putting something funky in the probe macro value, like the line it's spitting out, or if the probe macro just doesn't allow those larger numbers.
Oh, it does, because I do that all the time.
Yours do. I
But
have
I
a
load
cold
the
fire
machine.
controller.
And I also load my machine in for my settings, or for my, I load my machine in with my setup.
My macros are different than yours.
That could be. That is true.
My macros are different. My post is
But
different.
is your work offsets the same? Like, does it go 59 and then it goes like 154, 0.01,
Yeah.
0.02, 0.03, all that?
Yes, it does do that. I think I have like 20 offsets or something like that.
I have 100, I think.
Yeah, good for you. I also only get 20 tools.
Yeah, but that's just because you get the umbrella. I hate that about those machines.
But I don't even have like H offsets, which is apparently a thing that other, like the newer machines get.
I don't know if I have H offsets. If I do, I
You
don't know
do.
how to find it. So
I do have tool life management. I didn't know that. I found that. Oh, and I found out how to look at the times.
yeah.
Turns out there was like a whole series of menus that I just didn't know existed. If you go to current commands and then hit page down, I had never done that. I didn't know those menus were there.
Oh yeah.
So I can see
Yeah.
things like active G codes now and cycle time counters.
Oh, that's good. So you did find your cycle time
I
counters.
did find my cycle time counter, yeah, and I've been using
Okay,
that.
that's good.
And I think there was a macro variables page in there.
Yep.
I can't get it to show up on my main page, but at least as far as I know, there's probably some magical button that I can hit. But I can see the macro variables.
Yeah. Yeah. Any advice that I could give you? Like you said, we've got different controllers, so I don't know what would
Yep.
translate and not.
I got my weird controller.
Not a weird controller. I was looking at a machine of the same vintage to replace the Tormach, so I could end up with one of those at some point, depending on if this machine sells.
There was a guy that was selling a 4-pack of mini mills. I was like, this is kind of tempting.
A 4
It was
pack.
literally 4 mini mills on a trailer. They were, however, in very rough shape.
Yeah.
I don't know what price they were. They would have been cheap based on their condition, but they were in bad shape.
Yeah. There was I had the perfect machine I wanted, and it sold so fast. I knew it would just by looking at it. It was basically a brand new 2021, well, brand new. It was a 2021 machine that had $140,000 of options that they wanted 80K for, and it had, I think, like 2,000 hours on it, if that. I mean, like looking at it, like looking at the photos, all the paint was immaculate, and like the only paint that was missing, if you look down in the auger, there's like a small line where it had run a handful of times, and it looked. I think the line in the paint from the auger running looked better than the one in our machine. So like it had this. It was probably in the same condition our machine's in
Yeah.
right now. So I was like, oh, I wanted that one so bad because it was like 60 grand off of what it would be new.
Yep.
So
One last administrative detail thing. I do have the art for the Kickstarter coins. I need to send that
woo-hoo!
over to Harrison at some point. It needs to kind of be stitched together. He sent it over as like 3, like he sent me over a couple of illustrations, and then like he put the words we wanted on a thing, and we need to like piece together where we wanted on the coin. But that's fine. He didn't charge me very much, so I think it's fair. Shout out to Adam C, with C spelled with like 4 E's or 5 E's. He does great work. He does a lot of illustrations and stuff. Adam C. That'll be our small business shout out.
There you go.
He is. It's like fast, good, and pretty reasonably priced. Though I think he likes me because I never ask for revisions or anything. I generally I give pretty detailed instructions, and then I just go with what he gives me, and so I think
Nothing
he
wrong
likes
with
me
that.
because I'm an easy customer. But yeah, so I have that. If you want a coin, join the Patreon. We made some arbitrary deadline that sometime next month. If you join before then, you get a coin. All existing members at a paid tier will get a coin. Sorry, free tier, you don't get a coin. We are doing not a Patreon. We are doing a listener meetup. You don't have to be a Patreon at IMTS. It'll take place on Monday, sometime in like mid-afternoon. It was going to be at the Pocket NC booth, but I have been informed by Pocket NC that they will not be having a booth. So our plans to raid their booth are no longer valid. So if you are going to be at IMTS, shoot me a message if we can borrow your booth. I might ask like Harvey because they'll be there.
I know there's some sales reps in my area that would be happy for us to go to their booth with a big group of people.
Okay. Yeah, if you want to ask them. Yeah,
So,
I've talked to Harvey before. I can't think of any other companies. I had a dumb interaction with Harvey, so I've never interacted with their social media again.
gotcha.
But not like they weren't rude or anything. They were just kind of clueless. I think it was like I was just talking to interns, and like they did not understand machining.
Gotcha.
And so I was like, I'm just kind of done with you guys. But that's what happens when you talk to marketing people about machining. That's fine. So I couldn't. Sile's not going to be there either. Tormach's not going to be there. Someone's going to be there.
There's going to be
I
a lot of
think Haas
other
would
things.
host us, but
yeah, just depends.
So if anybody knows anybody, if you know a guy
we'll come
who
up
knows
with
a guy.
something.
Otherwise, we will just choose a random booth and raid them.
There you go. Do we know anyone who's buying a machine like Grimsmo did, where they sticker bombed his machine?
Yeah.
If anyone's buying a machine that we can go like meet up beside and all pretend like we're going to try to buy it or something. Sticker bomb it. So
I know someone at Rego.
Oh, that'd be fun.
But all the companies that I actually interact with on a regular basis, they are not going to be there. Lakeshore, I don't think ever goes to IMTS. I've never interacted with AB Tools, but he is like part of the community, so he might take us.
We'll find something.
Yeah, we'll find somebody.
All right.
All right, choose a number between 1 and 10.
Oh, man. We started with 7, so let's go with 4.
Working hard in a little machine shop, tapping threads and turning metals non-stop. Every day a challenge we face. With our taps and patience, we'll ace this race. Greasy hands and sparks flying high.
I like this one.
The sound never dies. Small shop, big dreams. We're on our way. With taps and patience, we'll seize the day. Taps and patience.
That's okay. I guess I do need to do an outro now.
Yeah.
That was a good one. I like that. It had a good beat to it.
I remember that one. That one was supposed to be Irish pub rock.
Yeah, I was gonna say it did sound a little bit Irish. I was gonna make that comment. So no, that's good. So, anyways, guys, thanks for hanging out with us and listening to me rant passionately about my woes of machining stainless and not wanting to go slow. And hopefully you learned something or at least enjoyed. And I can't really think of anything else for this outro. I'm at a loss. But anyways, thanks for hanging out. This has been Harrison with Precision Ingenuity and AJ from Audacity Micro. Please like, share, and tell all your friends about us again. And we'll see you next time.
There will be more theme songs next time.